Okay, so even and odd functions, what are they? So these are properties that a function can have. So if you give me a function, it can either be an even function, it can be an odd function, or it can be neither. Okay. So a given function can be even. Okay, it's just the name, right? Don't think even numbers or anything like that. It's just the name for it. Can be even, odd, or neither. Okay. How do we tell if a function is even, odd, or neither? There is a rule for it. So a function is even if, and I should suggest everyone take notes for this, even if f of minus x is equal to f of x for all x in its domain. Okay, we've spoken about domains before. So when I say for all x, when I say for all x, I mean for all x in its domain. So I could give you the function root x, but only part of its domain. So not over all real numbers, maybe not over all positive numbers, maybe just from 1 to 2. That's its domain. It's a perfectly valid function. You need to check the evenness or oddness on its domain. Okay, please just remember that from what we covered before. It is odd if f of minus x is minus f of x for all x, and again, when I say for all x, I mean on its domain. There are a couple classic examples of this. Please take these down as some examples just to illustrate the idea of which ones are even, which one is odd, and then we'll draw some pictures so that you can visually see what's going on. Okay, so examples. Number 1. F of x equals x squared is even. Okay, now I'm just writing that down. You need to be convinced of that. How do we convince ourselves? Well, we look at the property and we show that it's true. So let's check f of minus x. So wherever you see an x, you now put a minus x. So this will be minus x squared. But minus x squared is just x squared. And x squared is just f of x. So look at the extreme left and right of the chain of inequalities. We started at f of minus x. We ended up at f of x. But that is precisely the condition for it to be even. Make sense? Okay. Number 2. F of x is equal to sine x is odd. Okay. Again, I'm just telling you this to convince yourself. Look back at the property. So we start off with f of minus x. So that will be sine of minus x. And we know from our trig identities, sine of minus theta is minus sine of theta, or sine of minus x is minus sine of x. So the minus can come out. But our original function was sine x, which was f. Now we've got minus sine x. So it's minus f of x. And again, if we go back to our properties, f of minus x, we started with that. We ended up with minus f of x, so that means it's odd. Number 3, f of x equals x squared plus x is neither even nor odd. Okay, how do we show this? Well, we need to show that it doesn't satisfy property 1 for even, and it doesn't satisfy property 2 for odd. If it doesn't satisfy either of them, well, it's neither of them. So we start f of minus x. That's going to be minus x squared plus minus x. Okay, and then I put it in brackets just so that you can see wherever there was an x, there's now a minus x. The first bracket, since we're squaring, we can write that as x squared. Good. Minus x. Okay. But our original function was x squared plus x. Now we have x squared minus x. It's not minus f of x, and it's not f of x, it's neither. So it is not even or odd. Okay, everyone with me still? Okay, so those are the two checks that we need to worry about. Checking if it's even, checking if it's odd. If it doesn't satisfy either of them, it's neither. Okay, now what about the graphs of these? Okay, so if we were to sketch a function, we can check visually if it is even or odd. So from a sketch, we can see if it is even or odd or none. Okay, remember there's always a possibility that it's neither even nor odd. Okay, if you're still having problems with sketching graphs or sketching functions, please look at that Matric help guide. It is posted on the Learn page. It goes through the entire function section from grade 10, 11, and 12. Okay, so if you cannot sketch functions at this stage, please go and look at that booklet or come to me in my office. Okay, I can help you out. But do not sit here not knowing how to sketch these functions. Okay, so an even function is symmetric about the y-axis. Okay, so what do we mean by symmetric about the y-axis? We mean that the image on the right-hand side, if you flip it over, like a page in a book, you flip it over to the other side, you get exactly the same image back. So the classic example for this is just y equals x squared, like we had. Now think of this like a book. We've got one side of the page, another side. If we take this branch and literally fold it over onto the other side, we get exactly the same image. That's what we mean by symmetric. Okay, so if you can take the one side of the function, fold it over onto the other, if you get the same thing, we call it even. Okay, and on the flip side, an odd function is symmetric about the origin. Okay, so what do we mean by symmetric about the origin? We mean that the function looks something like this. Okay, classic example is x cubed. Okay, when we say symmetric about the origin, look at the top part, and if we do a little rotation down to the bottom part, we see that it's the same. Or, if we take this part, and we do a little rotation up to the first quadrant there, again it looks the same. So it's like a flip and then another flip. Yeah. Oh, sure. Okay, so that's what we mean by symmetric about the origin. Yeah.
Okay, when okay, since the full class was this venue is kind of small.
Yeah.
So yeah. Yeah, it's small. Okay.
Yeah.
All right.
Okay, sure. Okay, so that is symmetric about the origin. You've got this flipping action going on there. Okay, and again, the picture to keep in mind is y equals x cubed. You can see that top branch there is like a little flip rotation of that bottom branch there. Okay. Okay, so everyone okay with the visuals so far? So even, you flip the page like a book. Okay, same image on both sides. Here, it's a little flip rotation to get to the bottom quadrant there. Okay, so let's have a look at the properties of these functions. Okay, so there's a number of properties. We're going to have to prove them. So the first two I will prove for you, and then you can see how these proofs are laid out. Then there's a number of them afterwards. I will leave that for homework for you to try. Okay, remember the homework is not compulsory. I'm not going to check on you. If you do need help, you can email me or you can come to my office. I'll be happy to help you out with that. Okay, so number one. A function that is both even and odd must be the zero function. Okay, so that is our statement. We need to prove this. Okay, so I know not everyone likes proofs. Okay, maybe some people do like proofs, but it is important to know. Okay, it is important to know, number one, given a mathematical statement, how do you read it, like here, and convert it into some maths so that you can use it? And number two, how do you prove that it is correct or not? Okay. So, firstly, let's read through it slowly and see what we need to get started. A function, so we know immediately what we're working with, that is both even, we know number one, it must be even, so we know it satisfies the even property. So that's the first thing. And odd. So and means it satisfies both properties at the same time. So it satisfies the property even and the property odd. Both are true. Okay, so that's our starting point. That's where we start. Must be the zero function. So that's our end goal. Wherever we start, in this case, it's both even and odd, our proof needs to go something, 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 zero function. Because that's the end goal, must be the zero function. Does everyone understand that? Okay, so the beginning of the statement, that's where we start with the proof. Something, 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 end of the statement, that's the goal of the proof. That should be what we conclude. So let's start. Okay, so the function is even. We know what it means to be even. So let f be an even function and an odd function. Sorry, that's underlined there, and an odd function. Okay, so that was our beginning bit of the statement. Now we need to translate that into some math so that we can work with it. The way we do that is with the properties. So since f is even, we know that f of minus x is equal to f of x. Why? Since it's even. So we got a statement, we got a reason. Okay, we also know f of minus x is minus f of x, since f is odd. Okay, so we've converted the statement there into some algebra stuff there that we can then work with. Okay, so let's call these two equations equation 1 and equation 2. Okay, now I'm going to rewrite them, but for equation 2 I'm going to do a little bit of manipulation. You'll see why now. So equation 1 I'm going to leave as is. Equation 2, I'm going to take the minus sign over to the other side. Okay, the statement's still true. I just put the minus on the other side. Okay, now I'm going to take these two equations and I'm going to add them. Okay, how do we add equations? Well, we add the left-hand side, we add the right-hand side. So, adding the left-hand side, what do we get? F of minus x minus f of minus x. Okay, I hope you see where we're going with this. On the other side, f of x plus f of x, well, that's two of them. F of minus x minus f of minus x. Okay, don't worry too much about the f of minus x and so on. It's like we're having a minus a. It's 0. Okay, now we've got a 2 that we need to worry about, but that's fine. Divide both sides by 2. And we're done. F of x equals 0. So that is the end of the proof, because that's what we were trying to show. We were trying to show that the function is the 0 function. In other words, it's 0. Okay, so that is the idea of a mathematical proof. You got your starting points, something, 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 what you want to show. Now, the way I did it, that middle part there, okay, that's not entirely clear for each proof. That's up to you to figure out what you need to do. That's why I said something, 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 right? It's up to you to figure out. That's the whole idea of proving things. So this is just one way of showing it. This is what I came up with. You might have a different way of showing it. If you get the same conclusion, it's perfectly fine. Okay. If they both show the same thing, your proof and my proof are equally valid. Okay, but this is just a starting point to show you what you need to be thinking about with regards to a proof. Okay, and of course, with all maths things, becoming an expert in it requires lots of practice. Okay, so you can't just look at my proof and now say, okay, I can do another proof. If I give you another one, the way you do the proof might be completely different. That's why you need to practice lots of proofs. Okay, any questions on this? Yes? The definition part. Okay, here. So the beginning said that a function is even and odd. So here, the first stage there, we know that f of minus x equals f of x because that's the definition for odd. Then f of minus x equals minus f of x, even there, and then f of minus x equals minus f of x, that's the definition for odd. So that's just from the definition. Okay, and then from that, we get equation 1 and 2, and we just add them to get to our conclusion. Okay. Okay, so your start of your proofs is always something that's given or something that is known. Okay, so you never need to make up where you start. That's always given. Either, like here, a function is even and odd, that's the start. So we start with that. I don't explicitly give you the definitions for that because that's in your notes. You know what that is now. Okay. Okay, let's look at the second one. If a function is odd, then the absolute value, we looked at that last time, absolute value of the function is even. Okay, that's our statement. We have a starting point. If a function is odd, that's our start. That's what we begin with. Then, the absolute value of the function is even. That's what we need to show. Make sense? Okay, so that's how we go from the statement to the beginnings of a proof. Okay, so function must be odd. So let's take an odd function. Let f be an odd function. Okay, but that's still words, right? That's not going to help us with the maths. Let's convert this into the definition that we know. So if it's odd, it satisfies the odd property. So f of minus x equals minus f of x, since f is odd. Now we can work with that. Okay. Okay, so that's a good start. What do we want to show? We want to show that the absolute value of this function is then even. So let's come up with a new function that's the absolute value of this f. Let g of x be the absolute value of f of x. Okay? Now we want to show that this absolute value f of x is even. Okay, that's the end goal. That's this bit here. The absolute value of the function is even. How do we show something is even? Well, it must satisfy the even property. So let's just check. We know what the function is. We can check if it's even or odd. Let's see what it is. How do we check if it's even or odd? We take g of minus x and see does that equal g of x. If it does, it's even. If it doesn't, it's not. G of minus x. Okay, what's g? G is the absolute value of f of x. So we put that in. Okay, now we might be a bit stuck. How do we evaluate that? Okay, well, we're not stuck because f of minus x is minus f of x because we know f is odd. Okay, so that inside part, that f of minus x, we can replace that with minus f of x because it's odd. So our next line will be absolute value minus f of x. Reason, since f is odd. Okay, so I'm just rewriting it for emphasis. We did say it at the beginning. Okay, now, again, what do we do next? What do we want to show? We want to show that we get back to g of x. Now here we have the absolute value of something that could be negative, could be positive, right, because of that minus sign. What's the absolute value of something? It's the positive version of whatever it is. So the absolute value of minus f of x, that's just the absolute value of f of x. That minus doesn't do anything. Whether it was positive or negative, the minus goes away. Yes?
So how do you get to absolute value of minus x?
I used the definition of g. Okay, so that is how g is defined. We want to check if g is even, so we substitute minus x and see if we get back to g. Okay. Anyone else stuck with that? Yes.
Is it because, so you got f minus x absolute value is because you say substituted negative x in
Yes. Yeah. So here, there, and there. So however we define g, so g of x equals absolute value f of x, g of 2x would be absolute value f of 2x. Or g of minus x will be absolute value f of minus x. Whatever you do on the one side, you do to the other. Okay. Or g of x minus 1, that's f of x minus 1 on the other side. Okay. Now, as we said, absolute value, that minus, that doesn't do anything. So we can get rid of it, and that will just be absolute value f of x. Right? That minus, that goes away. Just a little note on that, if you want to write here, absolute value minus k, that's just absolute value of k. Okay, the minus goes away. Okay, there are more properties with absolute value. You can have a look in the notes there. But the main thing is that the absolute value of something is just the positive of that something. Okay, that's what we're using in this case. Now, absolute value f of x, that should look familiar. If we go back up a bit, oh, that's just g. Okay, so let's zoom out to show everything here. Okay, so we've got this long chain of equalities. Over there, where we started, g of minus x. Something, 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 g of x. We have successfully shown that it is even, because we can ignore all the in-between bits. G of minus x equals g of x. Therefore, g is even. And if g is even, the absolute value of f of x is therefore even. Yeah, and that's what we wanted to show. Okay, makes sense? Okay, so whatever statement we get, that always gives us the starting point. We substitute our definitions, in this case, what an even function is, what an odd function is. You look at the end of the statement to see what we need to get to, and we need to show that. Okay, the in-between steps, that's up to you to figure out. Okay, a lot of the proofs might be similar with these in-between steps. So if you do enough proofs, you can get an idea of what needs to be done. Okay, any questions on these two before we move on? So everyone's okay with that? Okay, please make sure you understand each of the steps and why we actually did that particular thing. Okay, some homework problems, and then we'll go through these in the next lecture. But you can try them on the weekend, and then I'll give you the solutions next week during our double. Okay, please try them out yourself before you look in the notes or online or anything. The reason is, if you're given a proof and you need to try to figure it out, as soon as you look at what the solution is, you think it's easy to do, right? Because you see the solution, you think, I could have done that. Or maybe you couldn't have, right? So try it out for yourself. Spend an hour if you need to. Really think about it. And if you're like 100% stuck, okay, then look at the solution and see what you could have done. Okay, but the second you look at a solution for a proof, there goes all your learning opportunity for that. Okay, please trust me on that. Okay, prove the following. Okay, so we've got 7 over here. Again, you don't need to do all 7. Have a look for something that you can do, and then try set it out like we did for those previous 2. Okay, so number 1, the sum of 2 even functions is even. Okay, number 2, the sum of 2 odd functions is odd. Okay. Again, you've got your starting point, sum of 2 odd functions. We know what the sum of 2 functions is. We know what an odd function is. What do we want to show? We want to show that the sum is odd. How do we show that something is odd? You use the definition of something being odd. Okay, number 3. The difference between 2 odd functions is odd. Okay. Number 4, the difference between 2 even functions is even. Okay. Number 5, the product of 2 even functions is even. Okay. Number 6, the product of 2 odd functions is even. sorry, is even. Okay, and number 7, the product of an even function and an odd function is odd. Okay. Okay, so again, not for marks or anything, it's not compulsory, but try some of them out on the weekend, and then in the double, we'll go through all of the solutions. Okay, so please give them a go before you see the solutions. Okay, like I said, once you've seen the solution, there goes the chance of trying to do it for yourself. Okay, so the thing with proofs is you have to try it for yourself to learn. You don't learn how to do proofs by reading someone else's proof. Okay, you need to work at it. Okay, everyone got that copy down? Okay. Okay, and then there's a few more proofs with even and odd functions, but that involves the composition of functions. But like I said in the last lecture, we're only going to cover that next week. Okay, so I will add to the list after we do composition. Okay, but last little thing for today, even and odd decomposition. Okay, so for now this might seem a bit odd, like why are we bothering with this? But later on we'll see that this is quite important. Okay, especially for end of next year. So quite a bit of wait until we see some uses for this, but later on we will see where this is used. Okay, so every function can be written as the sum of an even function and an odd function. Okay, and this is for every function. Okay, so in our statement, given any function, okay, you can give me whatever you like, we can always write it as the sum of an even function plus an odd function. Okay, so let's prove this, and then we'll see a couple examples of it. Okay, so the proof, we start off with any function, so let's say f of x. Okay, so what I'm going to do is rewrite this f of x in a pretty complicated way, but we'll see that it gives us the proof of this quite quickly. So this is going to be written as 1/2 f of x plus f of x. Okay, seems a bit weird, but we'll see where this goes. So f of x plus f of x, that's 2f of x. We've got the half in front. That cancels the 2, so we're just left with f of x again. Now I'm going to add 0, but I'm going to add it in a particular way. I'm going to add f of minus x, and then I'm going to subtract f of minus x. So if I add something and then immediately subtract it, I haven't really added anything at all. So my original statement about 2f of x over 2 gives f of x, that stands. Okay, that's just 0. It's a complicated way of writing 0, but it's still 0. Okay, now I'm going to do a little bit of rearranging, and then some of you might see this immediately. Okay, so I'm going to write this as 1/2 f of x plus f of minus x. So this plus f of minus x, I am attaching it to one of those f of x's at the beginning. plus 1/2, and then I'm going to group the remaining parts, the f of x and the f of minus x that's left over. Okay, a little bit of rearranging. I haven't done much there. That first grouping there, I'm going to define that as f sub e of x, e for even. I'm just calling it that. We still need to show that it's even, but for now it's just the name. That second grouping over there, I'm going to call that f sub o for odd. And again, that's just the name. We still need to prove it. Okay, so my claim is that that first function is even, and I claim that that second function is odd. So in the end, what do we get? We get f of x is equal to an even function, strictly even, plus an odd function, which is what we wanted to show. Okay, but we're not done yet. Just because I call it even doesn't make it even. We need to show. Need to show, number one, that the thing I called the even function is actually even. And that's what we need to show. It's even. If we put minus x, we get back the function. And secondly, the thing I called odd, we need to show that it is actually odd. If I can show these two, then it means that any function is the sum of something even and something odd. Okay, so let's show number one. Okay, so we start off with that left-hand side bit. We substitute minus x wherever we see an x, and we see what happens. Okay, remember how this is defined. This is 1/2 f of x over there. F of x plus f of minus x. Now instead of x, I'm going to put in minus x. Notice on the second term I have two minus signs because originally there was one minus sign. Now I'm substituting minus x, so it's minus x. Okay, please keep track of your signs there. So over here, there was f of minus x. I'm substituting minus x, so it's minus x. Anyone lost with that? Okay. Now a little bit of simplification. This is going to be 1/2 f of minus x plus minus and a minus. They cancel, so that's just f of x. Okay, so we could stop here, but if we just go back to the definition, here it's f of x plus f of minus x. Here we've got it the other way around, but that's fine. We can just swap them around. So that's 1/2 f of x plus f of minus x. That doesn't matter too much. Okay, a plus b is b plus a, but it's just so that it looks like what we started with. Okay, but this is exactly what we started with. So this is f sub e of x. We started with f sub e minus x. We ended with f sub e of x. So it must be even. So I called it even, and in fact it is even. Make sense? Okay, now we just need to show that f odd is in fact f odd. Sorry, that should be a minus x. Okay, remember how it's defined. It was f of x minus f of minus x. So we put in the minus x now. Okay. One more bracket there. Okay. Okay, so similar to what we did before, we substitute minus x, and again here we've got the double minus sign because this was f of minus x. Now we're substituting minus x, so it's minus x. Anybody lost with that? Okay. So, same as before, the minus and the minus, they cancel. So this is going to be 1/2 f of minus x minus f of x. Okay, similar to what we had before, we originally had for f odd, f of x minus f of minus x. These have swapped, but that's fine. If we multiply by -1, they go back to where they should be. So, taking out the minus, okay, and we end up with this. So, with the minus out in front, the leftover part there is exactly the definition for f odd. Now with a minus in front. Okay, so quick recap. We started with f odd of minus x, something, something, something. We ended up with minus f odd of x. But that's the definition for it to be odd. So I called it odd, and it is in fact odd. Therefore, I'm not going to write the full statement out again, but the statement is true. Okay. So given any function, we can write it using this method as an even part plus an odd part. Okay. Now there is a little extra bit to this. It can be uniquely written this way. So when mathematicians say uniquely written this way, they mean that there's only one way to write it. So here I wrote it, if we go back up here, like this, with those two brackets, those two definitions. Maybe there was a different way of writing it. In fact, there isn't. There's only one way of writing that. Proving that is a bit too much for us, but just know that this is the only way to do it. Okay. But here in this statement, I did leave that out. Okay, so you don't need to worry about uniqueness. We won't be covering any of that. Okay, let's have a look at an example. So here, just a crazy function I made up. We want to show, can we write this as an even part and an odd part? Now this is quite easy to do. We just look at all the terms and see, are the terms even or odd? If the terms are even, we can add them together and we get something that's even again. Okay, you're going to be proving that on the weekend. If we have two odd things together, we can add them together and it will be odd again. If we have an odd thing times an odd thing, that's again in your homework there, the result is even. Good. Okay, so we don't even need to use this definition here, although we could. This bit over there, we could write it like this. We'll get the same answer. So you could blindly just write it like that. You'll get the same thing. Or you can do it by inspection and see, is it even, is it odd? And we know the properties. The sum of the even is even. Product of even and odd is odd, and so on. Okay, so let's do it by inspection. You can do it the long way for homework. The first term, x squared, even or odd? Even. Good. Okay. Just x by itself, even or odd? Odd. Sine of x, even or odd? Odd. Sine is odd. Sine function is odd function. An odd function times an odd function is even. So individually, odd and odd, together, even. Okay, so it's just by inspection. So individually, let's say there and there are odd, together they are even again. You'll prove that on the weekend. X cubed, even or odd? Odd. Okay, if I have an even function and an even function and I add them together, what do I get? Even. Okay, so I can write this as bracket x squared plus x sine x, close bracket, just to show some separation there, and x cubed for the other one. First bracket we know is even, second bracket we know is odd, so this f of x I randomly came up with is now written as the sum of an even part and an odd part. Okay, make sense? Okay. Okay, homework, show this the long way. In other words, calculate f even, that's 1/2 f of x plus f of minus x, f odd, 1/2 f of x minus f of minus x. And you should get, for f even, you should get the first bracket. For f odd, you should get the second bracket. Okay, so try it out the long way. You should get the same answer. Okay. And then the final homework question for today. Write f of x, x plus 2 to the x plus x squared as f even plus f odd. Okay, now this one, a little bit more tricky because we can't do it by inspection. Why? X, even or odd? Odd. X squared? 2 to the x? Neither. It's not even, it's not odd, so where does it go? We can't write it like we had before. It's not going to go to the first bracket, it's not going to go to the second. We have to do it with that long way. Okay, so keep that in mind. If you do want to write a function as even or odd, sometimes you can do it by inspection, but this definition way here will always work. Okay, so just keep that in mind when you're doing these decompositions. Okay, any questions on this even and odd stuff or the proofs? Okay, so during the double next week, we will be going through the next section on composition of functions. Okay, if you do need to revise your definitions of domain and range, how you find the domain, how you find the range, please go through them over the weekend. If you need more help, I'm available in my office today. Please come get some help on that before we get to composition. Okay, because when we do composition, I'm not going to go over domain and range again. I'm going to give you a function, and we're going to go straight into finding the domain, finding the range. Okay, so if you don't know how to find those, please go over it this weekend or come see me in my office. Okay, so I'll see you next week.